So, hi everyone, and thanks for joining. And in this talk, we're going to be taking a look at some tools that you can use for working with Excel in Java. And as Java developers, you may be wondering whether or not you need to care about Excel at all. And I hope by the end of this talk, we'll have answered that. Just to quickly introduce myself, first of all, I'm Tony Roberts, as Barry said. I worked in finance as a developer for many years, both on the buy side and the sell side. And as some of you may know, that's an industry that really runs on spreadsheets. A few years back, I launched a product, Jinx, and that's for developers to write Excel add-ins using Java or using any JVM language. In fact, we'll take a look at that a bit later in this talk. So. Yeah, so as developers, it's really easy to dismiss Excel as something that we don't need to care about, and many of you, I'm sure, would have been burnt in the past by users creating super complex magic spreadsheets that are impossible to maintain and support. And so it's kind of understandable that you now might want to avoid using Excel at all costs. But it's kind of missing the point of what Excel is. It's not really a tool built primarily for developers. It's a tool built for non-developer business users who need to work with data. For a lot of us, if we think about what our role is as a developer, it's really to support one or more business functions in a company, whether that's directly, like working as a quant developer on a trading desk, or indirectly by developing applications or reporting or automating processes for areas of the business. But in all of those kind of situations, the users that we're supporting are more than likely using Excel. I speak to lots of people and they say, oh yeah, in my company we don't use Excel. But when you get past talking to developers and you start talking to the actual business users, you often find that that's just simply not true. And actually, the developers aren't interested in using Excel, but all of the end users are doing a lot of their day-to-day work in Excel. So often there's a lot we can do better to help those users. When we sort of step back and take off our developers' hats and think about it, it's kind of obvious why these business users really like Excel. They're not completely technical, but increasingly they're semi-technical. They know what they need to do, and for them, Excel is like this really amazing UI for them to be able to put together ideas and build stuff, but without having to learn how to write code or that kind of stuff. You might say, well, rather than using Excel, they should get the IT team to build them out, all the singing and dancing applications for everything they need. But, sure they could, but in most organizations, there's just not enough resource to do that. And businesses tend to move quicker than that. So by the time they put a request into IT for, some fancy system, then it will take months or years to develop. And by that time, the business has moved on and the requirements have changed. So for sort of quick ad hoc things, Excel is really just how they like to work. This, as I kind of said on the previous slide, what I really like to think about when I'm working with teams is kind of how can I help. So I'm not here to try and convince you to use Excel, but what I want to try and get across is that we need to match what we do as a developer to what the business actually needs, and how we can best do that by giving them better tools or by automating processes, but doing that in a way that's sympathetic to how they want to work. So if you're working with users that are comfortable in Excel and already using Excel, then building out a complete replacement for what they already have isn't always the quickest or most cost-effective thing to do, and it certainly doesn't guarantee that they won't continue to use Excel, behind your back anyway. So I think sometimes we need to just ask ourselves, how can we best give the users what they want under the assumption that really they want to continue using Excel? We've got a few different options here. Often we can just export static reports, just kind of daily reports, that kind of stuff. Also, we can go a bit further and we can automate Excel to simplify repetitive tasks. And finally, we can we can go the whole hog and extend the functionality of Excel by writing add-ins. And we'll look at those in a little bit of detail kind of in the rest of this talk. So I want to start off with kind of the simplest approach, which is just writing static Excels to output from Java into Excel. Often we might do this just by writing a CSV report. So you might have something which does some calculations or gets some data from a database and does a bunch of stuff and then just outputs it as a CSV report. And that's great. You might sort of go home and think, yeah, I've done my job. The user's now got the data that they want. But if you think about what the user's going to do with that, the first thing they're going to do is open that file in Excel. So they might take that file, auto fit the columns, format some columns as percentages or dollar amounts or whatever it is, color some things, and then include that in a report which they're sending to high-level management or whatever they need to do with it. But if you think about what a lot of our users kind of end up doing, some of these tasks are quite repetitive. This might be a report that they get sent every day, and so they're doing those simple formatting options like every single day. And when you put it in that context, you can kind of see why writing VBA macros to make their lives simpler is really appealing to them. And I think as developers, what we can try and do is try and match what we give people to what they actually need to get their job done, slightly better. So I wanted to jump in now and just talk about kind of how we can do this from Java. And specifically, there's a package called apache-poi or poi, which some of you might have seen before. But I'm just going to jump into an actual kind of live demo of what we can do. To begin with, what I've got is as some dummy data is just this simple CSV file. So this would typically be a lot larger than this, but this is the kind of thing that we might today produce for our users. What I want to show you is rather than just producing that CSV report, what we can do is use apache-poi to generate an Excel file from that. So in this file here, all this code's on GitHub as well, so I'll give you a link to that later. But here we can create a workbook, create a sheet in that workbook, and then write each one of these records from this CSV file, or it could be from whatever source you want into Excel. So if I run this now, it should save a workbook, and it's just saved it here. So if I open this up, there we go. So I've written an Excel file, but it's still it still doesn't have any formatting. It doesn't look that great. It's really no better than what we would have given them if we were given a CSV file. So there's a little bit more we can do with this. If I go back here, I've got a second function which actually writes a formatted report. So this loop here is doing the same thing again, writing each cell to the workbook, but this time, as well as setting the value, it's also setting this cell style. So here I've created a style for amounts, and I've got a style for percentages, and this is all just part of the apache-poi library. So if I run that now, save that workbook again, and then open it up. Now I've got this report, so nicely formatted. I've got dollar amounts as dollar amounts, percentage amounts as percentage amounts, and I've added some colors. So this is much more like, now they could just take this, copy it into their other report or do whatever they need to it. And we've saved them a little bit of time, but every day we've saved them a bit of aggro. We can still do a little bit more. And here, what I wanted to show was that as well as formatting the report, so I'm writing the same report here, we can also write an extra row with some formulas in. So what I'm doing here is creating a new cell, but then calling set cell formula. And when I run this, you'll see what it does. So run that again. And now we've got this much nicer report, which has all of the formatting that we had before, but then on the last row, we've actually got an Excel formula in here. So this is now much more like something that our end users could actually use. So this could be potentially a much more complicated report, but rather than them having to pull in CSV data and then copy and munge it into the format that they want, we can actually give them something in the format that they want first time around. So that's kind of a big improvement from just doing CSV. So that's great, but there are some limitations, as you can imagine. The user can run the report and they might rerun it, but at the end of the day, it's just a static report. And Excel is much more than just a tool for viewing static reports. Really, I like to think of it as like an insanely flexible UI tool disguised as a spreadsheet. Now, traditionally, Excel is automated or scripted using VBA, but just kind of imagine for a moment that instead of writing that awful VBA code stuck in spreadsheets and impossible to manage, we could do exactly the same thing, but from a Java application. So we have a Java application that's in control of Excel and is automating it in the same way that we'd do VBA. Now, we can actually do that because Excel has a scriptable interface. And through that scriptable interface, we can do anything that could previously be done in VBA. It's called COM. So that might be causing a bit of fear among some of you, but it's not as scary as you think. And COM's a pretty ancient Microsoft technology, but it is pretty widely used throughout Windows. It may be notoriously difficult to work with, but I kind of believe that really stems from trying to call it from C and C++, which is quite difficult. Calling it from Java is actually, I think you'll see in a minute, it's much easier than you might think. What I'm going to show you next is this com4j package. So com4j is like a general purpose COM bridge to Java. And the way that it works is you pre-generate Java classes according to a COM type library. That can be a little bit fiddly if you're not really sure what you're doing. So if you're not really that confident using COM, then there's a bit of a learning curve there. But for Excel, there's these pre-built com4j Excel classes which you can download from the Excel Java org on GitHub. So this Jinx com4j, and we'll have a look at that now. So I've got another demo lined up. So this example is using, like I said, this com4j package, and here we're calling this getActive object, this is what's going to actually get us the handle to the Excel application. And here I'm using the application class that's from this Jinx com4j sort of bridge package. Again, all this code is going to be on GitHub, so don't worry about if you're not following too carefully. But the key thing to note here is this application object is actually identical to what you're calling from VBA. So anything we can do through VBA, we can do through this. And I just want to show that with a simple example here. So I'm getting the application, and then in this simple example, all I'm doing is getting the current selection. This query interface is a kind of COM thing. It's a bit like casting, but I'm getting the selection, I'm getting it as a range object, and then I'm just setting the value property on it. So if I select some stuff in here, and then run this, what we'll see straight away, I've interacted with Excel, but from a Java application. So rather than, IntelliJ, you could imagine this could be a desktop application that your users are using alongside Excel, and you can interact sort of back and forth that way. And I wanted to show you a slightly different, but still like fairly simple example of how an application like that can look. So I've got a second example, write blotter, and this is a slightly financy example. But if you're not aware of finance, then I think you'll still be able to follow along. But what this example is going to do is really just set up like a template spreadsheet. So you could imagine in your Java application, you'd come along and a user would say, okay, I want to do this trade blotter. And they would then go ahead and click this button, which then adds some columns here. What this trade blotter is kind of supposed to represent is a very, very simplified version of what people might do on a trading desk, where they're doing trades throughout the day, but they need to be able to put those trades into a PMS system or something like that. Usually that would mean going from Excel and copying and pasting values into another system, which can lead to errors, but it also reduces efficiency because the user's having to go from one application where they might have structured the trades that they want to execute and then they're having to go to another system where they need to like copy and paste them all in. So just put some dummy data in here, whatever it is, like that. So these are the trades that they want to book into the system. The next bit of the example is this read trade blotter method. And what this is doing is like the reverse. So far we've shown writing to Excel, and this is going to show pulling values out of Excel. So similar as before, we're getting a range. Here we're doing like a select down, same as in VBA, and then we're iterating over the rows, getting the values, doing some validation, and then here we would, this is where we'd forward them to our actual like system where they'd be put in a database or whatever they are, and writing some statuses back to the user so they can see what's going on. So if I run that now, what you'll see is immediately I've got some feedback. This one's saying it's booked, this one's saying it's an error, and it's saying price needs to be greater than 0. So I can correct that, run it again, and there we go. Now both my trades are booked. So we can actually integrate kind of calling Excel both ways into our Java applications in this way using COM, and it's kind of pretty straightforward really for what's going on, given that we're talking to between two different applications here. There's not really very much code to it. Okay, so what I wanted to go on to next is kind of really what I think is the sweet spot of using Excel and Java together, and that's writing Excel add-ins. So if the users are already working in Excel, then anytime they have to leave Excel and go into another application, that's it sort of slows them down, or there's potential for things to go wrong, or whatever. A lot of users would really just rather do all of their work in Excel and have tools added into Excel that can then connect to the various external systems and stuff like that. So I'm not talking here about writing a load of VBA glue code or anything like that. What I'm talking about is writing like proper Excel add-ins, but entirely in Java, using the same Java tools that we use day to day. And that means that the Java code is compiled into jars in the same way as normal, and they're tested, and we use CI and all that kind of stuff. They're not just bundled into Excel spreadsheets in the way that VBA code is. Yeah, so as I said, giving the users the tools that they need. Anyway, for a long time, the only way to write an Excel add-in was to either write it in C or C++, or write it in C#. And those are kind of like, the least worst choices, because there was no good way to write Excel add-ins in most other languages. Now, I've had quite a bit of experience with this. I actually launched a different product called Pixel about 10 years ago. And that was a tool for bridging Excel and Python. And what I sort of found a couple of years ago was that I was talking to someone else, and they were saying, oh yeah, it'd be great if we could write Excel add-ins in Java as well. And I was kind of taken aback, because I thought, well, Java's been around for so long, like surely this must be possible already. But I did a bit of research and looked around, and really there wasn't anything out there that could do it in a kind of nice, like stable, reliable way. So shortly after that, I launched Jinx. Having spent about 10 years, on and off developing Pixel, I had a massive head start, and the two products share an enormous amount of code. It's probably like about 95% same code. So right from the first release, Jinx was super stable and super reliable. Now, with Jinx, we can write fully featured Excel add-ins in Java or any JVM language, and that can be used to expose new Excel functions as worksheet functions, or stream in real-time data, or write macros, menus, ribbon bars, all that kind of stuff, and even pass Java objects between Excel functions. So I wanted to show you kind of how that looks now. Let me just pull up another example. Do a new workbook. Now, to get Jinx, you can go to the website exceljava.com and just download it from here. And what you get is a zip file, including the Excel add-in itself, and also a config file that is how you tell Jinx kind of what classes to load. And there's also tutorials on getting started and stuff like that. So I'm not going to go over kind of how to install it and how to get started too much here. I'm just going to dive in and show off a few features. So one of the really common things that people want to do is be able to write custom Excel functions. So if I had, let's just say I had a public method, something like this, whatever it is. Oops. So let's say that's, some amazing bit of analysis or whatever, and I wanted to expose that to Excel. All I have to do is add the Excel function annotation, and that's it. So now when I build this project, this is building this this jar file that this project's configured to build with some configuration that points Excel to that specific jar that I've just built. And now, without restarting Excel or anything, if it's worked, I should be able to do Excel func like that. So that's actually calling my Java code, which is kind of cool. And I can even, I'll just show you the config very quickly. Which I don't need these ones. But in here, I've got some settings here to say to use the Java debugger. And now if I run the remote debugger in IntelliJ, this isn't using a plugin or anything, this is just the standard IntelliJ remote debugger. Call this function again, then sure enough, I've hit my breakpoint, everything's come through correctly. So it's just running my Java code, but as an Excel function. And that's how most people tend to use Jinx for building out toolkits for people to use, like, on trading desks or researchers or whatever it is, using functions like this. And these functions can be pretty complex. They can return arrays, they can take arrays, they can pass Java objects between themselves and stuff. But anyway, that's it in a nutshell. I wanted to go back to the trade blotter example that we showed just a few seconds ago. I've basically got exactly the same code here, this read trade blotter thing, and where is it? There's a right trade blotter here. So the same kind of code here, but what I've done now is annotated them with this Excel action annotation. And what that lets us do is in the ribbon tab up here, this ribbon tab is just controlled by some XML that gets included in the jar. I can reference my action methods here, along with a bunch of other bits of metadata, and then rebuild this jar. And then now, if you see here, we've now got those two buttons that have just kind of appeared just by rebuilding that jar. So now, rather than having an external application where we say, create the blotter and another button say, do that, now we've got a button right in Excel that's doing exactly the same thing using the same code as before. So whatever it is, and then book trades. So you see here, the user's feels a lot more like the actual Java application is really integrated into their workflow. They're not having to go in between different applications. The data's staying in Excel, but it's being persisted to a proper data store. So that, our sort of source of truth, if you like, is the trade database, not the Excel spreadsheet, but they're able to use Excel as a tool that works for them. I wanted to show one other example of a worksheet function that's a little bit more complicated than the one I just showed, just to give a more sort of real world example. So what I've got here is just the Black-Scholes option valuation formula, just written out as it's only a few lines of Java code. It's a pretty well known kind of function. So this is more like what someone working on a desk might want if they want some kind of valuation tools inside Excel. So I'm just going to put in spot strike, years for expiry, volatility, what was 20%, interest rate 1, no dividends, and we'll say it's cool. So from here now I can just call my Black-Scholes function. And that's given me a valuation there, I'm sure that's right. But what's interesting now is that, yeah, we could give the user some application where they could have like a little calculator screen or a website that calculates things. But what this lets them do is actually build their own tools. So we've given them a building block, but now they can go ahead and build like their own spreadsheet. So here I'm just calling that same function, but with a bunch of different values and then plotting that. So I've got a graph of just option value versus spot. But if I wanted to change it to see what does it look like as a put option, I can just do that straight away. And that's each time here, I'm calling this Java method and then updating the results in Excel. So I can, play around with this, change different things, whatever I want. And you see here from that one building block that we've given them, they can now build kind of the tools that make sense to them rather than being constrained by, the application that we've given them. The final thing I wanted to show, I think I'm almost out of time, just to kind of expand on this a little bit more, is using the same idea of a Black-Scholes pricer. Kind of how would you actually get, here I've got a lot of stuff. I'm passing in spot price, interest rate, volatility, all of this kind of stuff. Usually this would be fed in from Bloomberg or wherever. And we can actually get hold of that stuff as well. So what I've done, I've got this market data interface, which is really just like a noddy interface, just to show I've got things like from the market data object, I've got a method to get a spot price, get volatility, get its currency, get interest rates, these kind of things. And then I've got a mock one, which just has some hard-coded values. But in the Black-Scholes code, what I've got here is another function to say load market data. So what this would be doing kind of in a real situation is going out, making connections to Bloomberg, pulling data from a database, whatever it is, and then just returning this market data object. So it's actually returning an instance of this. And if I call that here, you can see what that looks like. So it just comes through as this sort of weird looking string, which is just a handle to that actual Java object that we've returned. So this thing here represents the actual Java market data object. And now here what I've got is a Black-Scholes 2 method, which rather than taking the spot price and everything discretely, just takes this market data object and a few other bits, extracts the data that it needs from the market data object, and then returns the same Black-Scholes that we had before. So now rather than having kind of everything out on the spreadsheet, I can now just pass in a ticker, what did I say, XYZ, I think, and then strike, let's say 250, years maturity 1, and let's do a call option again. And now I can call this Black-Scholes 2 thing. Let me just put a breakpoint here so we can see what's going on. Pass in this object and the other various little bits, call that. And now when we get called, what we've actually got here is this market data object that we returned from here. So we've actually passed a whole Java object through Excel and back into another Excel function. And there we go, it's come back with a price there. Cool. So that was kind of like a real quick tour of that, and I hope you got something useful for it. If you want to have a look at the slides and the source code, I've put it all up on GitHub here. If you just go to Excel Java, you'll find it, the LJC one. As I said, you can download Jinx and try it out. And if you've got any questions, then I think we may have a bit of time now, but just email me and I'll be happy to chat.